The indicator sponge is a discrepant event, and it's an activity that's a lot of fun to work with and for students to kind of get them guessing. I have a red sponge. Let's see what happens with it. If I take this red sponge and I place it into the beaker of red liquid, when I put it in the red liquid, it turned blue. The red sponge turned blue? Okay. Well, all right. Let's squeeze this out. There's not any blue coming out of it, is there? Okay. Well, I wonder what would happen if I put the blue sponge in the blue liquid. I wonder if I put it all in there. Well, I'll be. Look at that. And if I squeeze it, it's kind of interesting. Well, let me rinse this out in the sink here. Maybe there's something wrong with this sponge. I don't know. We'll try rinsing it out for just a moment and see if we can make this work. Okay, so it's nice and clean and it's all red. I'm going to put this into red solution. There it goes again. The sponge turned blue. Well, let's rinse it out. I wonder if, So we'll come back here to the sink and we're going to rinse this out. And I see red liquid coming out of it, but the sponge is blue. Let's try putting it back over here in this blue liquid. That's pretty interesting. So when the red sponge went in the red liquid, it turned blue. But when the blue sponge went in the blue liquid, it turned red. Now that's what you would have predicted, right? My students would say, Mr. Long, you messed up another demonstration. What'd you do? But the point is that it's a discrepant event. The sponge is a cellulose sponge, and it's been soaked in a biological stain called Congo red. The Congo red is not only a biological stain, but it's also an acid-base indicator. And while we typically tend to think of acids as being in the red region and bases being in the blue region, kind of like litmus, Congo red is actually the flip of that. Congo red happens to be red in base solution and blue in acid solution. So what I have here is a solution, a dilute solution of hydrochloric acid, which has red food coloring added to it so that it looks red. But when I dip the basic color, the red is the base color of the Congo red, into the red solution, it picks up the acid and it turns that red color to the acid form, which is blue. Then taking that now acidified Congo red solution and putting it into the blue solution, and as you can imagine, the blue solution is now a very dilute base solution of sodium hydroxide with blue food coloring added into it. When the blue sponge goes into the blue solution, then what happens is that the acid form, which is blue, now goes back to the base form, which is red. And that works opposite to what students are used to thinking about. Oftentimes, students will have worked with litmus in its acid and base forms as blue and red, blue to red, acid, as you remember the little rhyme to help you remember which one to switch there. But this is opposite. And so if you play this right, because all of us have had demonstrations that didn't demonstrate the way we thought they would. And so they're often useful, and if you play that up, say, ooh, I'm not so sure what was happening here, you can play that discrepant event along, and you can get the students to look and think about what's happening. This is a nice demonstration, and it will work a couple of different ways. Obviously, it works for when you're dealing with acids and bases and indicators. And they're familiar with universal indicator. We will have used that a number of times. They will be familiar perhaps with phenolphthalein. They will perhaps also be familiar with litmus. They've probably never seen Congo red and seen the color change that takes place with that. So that catches them a little bit by surprise. Another way that you can use this is, again, with a parent night or an open house night, or perhaps you're doing a science show for an elementary school. And this is a real colorful and a very easy demonstration that you can do. You don't have to explain the theory behind it. You can just simply tell them that these are acids and bases and that they're doing some color changes, and that the kids kind of work with that. So they would expect the red sponge in red solution to be red in color, but when it changes to blue, that really throws them a loop and then goes back the other direction. This sponge can be used a number of times in that form. Obviously, the cellulose at some point begins to degrade. Another way that you can use these sponges in a practical way is if you'll have some of these sponges in your lab area, some of them in the blue form, some of them in the red form. If you have a spill and you're not sure what that spill is, take a swipe with it with one of these Congo red stained sponges. And if it turns to the appropriate color, you know that you've got an acid spill or a base spill, and you can deal appropriately with it at that point. And the Congo red, once it's in the sponge, is good for the life of the sponge. It may fade slightly over time, but it will continue to work, and it's a practical way of helping you with your lab in terms of identifying unknown liquid spills, and then to be able to use it back and forth in the classroom as well. So if you play that up right, you can get a lot of fun out of that. The production notes will tell you how to produce the cellulose sponge from that, but it's essentially a cellulose sponge that's been soaked in a Congo red solution. It's a really fun activity. Play along with it with your students, and I think you'll have a great time.